Okay, so the last part that we did get to look at a while ago was patterns in the periodic table. Okay, we're filling out this sheet still, and what you're going to be looking at is at the very bottom, you're going to fill in the patterns part. There are trends in the periodic table, and there are three that we're going to talk about. The first one is called atomic radius, or radii. Atomic radii is just a pattern you can see in the periodic table that measures the size of the atoms. If you're looking at atom size, atoms tend to be smaller at the top of the chart and they tend to get bigger as you move down the chart. Also, your smaller atoms are going to tend to be on the right upper corner of the periodic table. And then they get bigger as you move down through the periodic table down towards the bottom left, are going to be your biggest atoms, okay? So what we did on our paper this morning was we drew on our periodic table, we drew some arrows. We just drew an arrow pointing to the left, saying that you're going to have an increase in atomic radius as you move towards the left of the chart. They tend to get bigger in size as you move across a row, and they tend to get bigger as you move down through the groups. And that makes sense, right? Because you're adding energy levels every time. All right. Now, let's talk about ionization energy. If you go back over here, ionization energy is just the amount of energy needed to remove the loosest electron from an atom, okay? It takes energy to pull off those valence electrons. Now, the less electrons you have out there, the less energy it takes, which is why then, if we look over here at the trend on the periodic table, as you move from left to right, it takes more and more energy to pull off these outermost electrons off of these guys right here, because they have more. They have like 6 or 7 valence electrons, and they're harder to pull off when there's more of them. These guys over here, there's not that many. So they're easier to pull off. It takes less energy. So energy increases as you move that way. Also, ionization energy increases as you move up through the groups, because the closer those electrons are to the nucleus, the harder they are to pull off. Okay, so that's ionization energy. Let's go look at the last trend, which is electronegativity. Electronegativity has to do with a measure of the ability of an atom to attract a shared pair of electrons more strongly to itself than another. So this has to do with bonding, and we're going to talk a lot more about electronegativity when we start talking about bonding. But basically, if two atoms are sharing a pair of electrons, one atom may have a stronger pull on that shared pair of electrons than the other atom. And whichever one has the stronger pull, that's called the more electronegative atom. So can you make predictions, though, on the periodic table? And the answer is yeah, sure you can. Okay, and the pattern, the trend, follows the same as ionization energy. These atoms, as you move from left to right, these guys over here have more electronegativity. And this one right here, fluorine, has the highest electronegativity on the chart. We really don't include the noble gases because they're unreactive. They don't really play well with others. They don't react at all. So they're just kind of there because they have a full outer shell, so they don't need to. But fluorine is the most active nonmetal, and it will bond readily because it really just needs one more electron. All of these guys do. They just need one more electron in order to be stable. So you have an increase as you move across these rows. They have higher and higher electronegativities, and so you have an increase in ionization energy and electronegativity. And same thing over here, you have an increase in ionization energy and electronegativity. All right, so you're going to see these patterns and these trends go on all the time, and we're going to talk about some more patterns later on. But for now, I hope that helps. Good luck.